So in the previous video, I used a cancellation example to explain the idea of hypothesis testing, the relationship between likelihood and the probability to the suspiciousness, right? So we interpreted the suspiciousness as a kind of probability. So I am going to generalize that framework to more statistical setup. So first step you have to do in testing is to define the hypothesis, of course. And in this example, P, let's say P is the probability of cancellation, and your null hypothesis is that probability of cancellation is 20%. And the alternative hypothesis assumes that the probability is greater than 20%. So that means if the probability is 20%, the customer is not abusing cancellations. So 20% may happen naturally. However, if the probability of cancellation is greater than 20%, then it's intentional. The cancellation is intentional, and the reservation was made knowing that it's going to be canceled. So this is, and P, the probability of cancellation, is the parameter of interest in this inference method. And it's not directly about P itself, but it's about a hypothesis. I specify that P equals to 20%. And the next thing you have to do is to choose the degree of strictness, you have to choose the cutoff, how much you are going to reject. So the level is called the significance level, which is usually denoted as alpha. So it's chosen among 1 or 5 or 10%. This is, later I'm going to show you what this probability means. Exactly, this is how much customers you are going to ban. Like if you're willing to ban 5 innocent customers, then that's your degree of strictness, how strict you are. Or if you're willing to ban 10%, then you are more strict. You ban a lot of customers. Even though a customer is very small, very little suspicious, still you may ban those customers. So the higher alpha is, the more rejections. More rejection means you believe that a customer is not abusing. But when you reject it, it means that now you believe that that customer is an abuser, right? So you believe that the customer is innocent, but when you reject that belief, it means the customer is an abuser, right? Then the next step, so we finished our setup, and what you do next is to define a statistic on which your decision is based. Of course, you are going to, in the first and second steps, you set up your hypothesis and how strict you are, your degree of rejections. And now you collect the data and you look at the data. You are going to use one statistic and you will compare the statistic, where the statistic is, with your belief, and that's called the test statistic. So it's usually denoted as T. So you are going to calculate the statistic T from the sample, and you make decision based on the value of T. If T is too large or too small, then you may reject your null hypothesis. That's a typical procedure. In our example, the test statistic is the number of cancellations. So you banning one customer is rejection of H0. So if the number of cancellation is too large, then the customer is suspicious and ban that guy. So that's the process of our previous example. So that can be interpreted as the test statistic was the number of cancellations. And later, in our later examples, we are going to use the sample mean again. So don't think it too seriously. It will be the sample mean because sample mean is the only statistic we know the distribution. Whose sampling distribution is known. So we are going to rely on the sampling distribution again in this chapter. Oh, here I'm saying that. So we are going to calculate the sampling distribution of the test statistic, but this clause is very important. We need distribution of the statistic when your belief is true. Because if you change your belief, the distribution will be different. So the distribution may take different shapes if your parameter is different, right? So we are particularly interested in the distribution when your belief was true. So you may simply assume that your belief is true until it's proven wrong, right? We maintain this thought process again. So now we just collected the data and we don't know if it's wrong. So I'm going to maintain my belief. The sampling distribution when you believe the null hypothesis is correct is called the null distribution. So the sampling distribution when the null hypothesis is true is the null distribution of the test statistic. And in our example, the null distribution is a binomial distribution with 20%, right? And here we have a binomial distribution with 20%, and here 20% in particular is coming from the null hypothesis. If the null hypothesis was wrong, then this probability would be a different number. If the probability was greater than 20%, then the binomial distribution would be different, right? So, but we don't care. We don't care about those guys. We only need the case where the null hypothesis is correct. And we maintain our belief until it's wrong. That's the main principle. Okay, then now we define the test statistic and we know the null hypothesis, null distribution. Then now you calculate the test statistic from the data and compare where it is. Think about where it is. You suppose that you obtain t test statistic equals to s, a certain value, right? And I will find the probability of outcomes of t which are less likely than s. So you observe s, and previously we calculated more suspicious customers. So you observe 3 cancellations, and we calculated probability of 3 or more cancellations because these guys are more and least equally suspicious. So we are interested in these guys. We are doing the same thing. If you observe S, then let's find all the cases where which is more suspicious than what you observe. That probability is called the p-value. P-value is the probability of more suspicious outcomes of the test statistic than what you observe. So you observe very unlikely value. Then what's even more suspicious outcomes? What's that probability? That's the p-value. If you observe a very likely value, then suspicious outcomes will be almost everything. So then your p-value will be very high. So in that sense, the smaller the p-value is, p-value in our previous example, the p-value was the ranking of the suspiciousness. The suspiciousness ranking. So customer A was ranked within top 5.79%. in terms of suspiciousness. This guy was this much suspicious, and customer B was even more suspicious within top 1%, 1.12%, right? So in this sense, those probabilities capture the ranking of how suspicious this outcome is, how unlikely this outcome is. So that's the p-value. If the p-value is too small, if the p-value is small, that means that observation is at the very top ranked within very small probability from the top. So very, very suspicious, right? So we have to reject H0 if it's too small. If it's too close to the most suspicious case, then you have to reject H0. The cutoff, then how much is too small? How much small is too small? This is defined by the significance level, which is the cutoff you set up in the first step. You had to define the significance level at the beginning of the test before reading the data. So this will be your cutoff. So if you set it as 5%, you are going to reject top 5% suspicious outcomes. If you set the cutoff at 10%, then you are going to reject more. You are going to reject the top 10% most suspicious outcomes. If you put 1%, you are rejecting this much, only 1% of outcomes. So this is the generalization of our hypothesis testing or our example. How to identify abusers. We cannot exactly know who is actually abuser or actually not, but still we can define who is more suspicious and less suspicious. Statistically, more suspicious is implied by more unlikely, or less likely, more unlikely. So that's the basic framework for hypothesis testing in general. So please make yourself familiar with these terms. So the test statistic and the null hypothesis, null distribution, p-value, significance level. In particular, I think in the end you are going to be familiar with all the other guys, but the most confusing term in statistics, in any statistics, the most confusing term or the most widely misunderstood value is p-value. So even frankly, my graduate students, I think they don't understand what's the p-value. If I ask them what is a p-value, they cannot answer that. But I hope now it's a good chance to fix your idea. So please think more carefully what's going on and try to get the main idea of what's going on and put you into that shoes and think about the problem. And I believe it helps. And it was really hard for me when I was a student. My teacher did not teach this way. So I put a lot of effort to explain at this level. I think I'm doing very well. I'm doing a good. I'm very proud of my example and explanation. So believe me and repeat if you cannot understand at once, and ask for help if you need help. If you have difficulties, reach out to me. Okay, thank you for watching the video. In the next video, I will use a more concrete numerical example, and I will show you how to calculate and how to make the final decision from the data. See you.